Welcome to this deep dive. We're cracking open your source material today,
Mm-hmm.
looking at the real basics of statistics. Collecting, organizing, understanding data.
Yeah, the fundamentals. We've got a source that breaks it down pretty clearly, step by step.
Right. So our mission is to kind of unpack what data actually is, how we start making sense of it.
And maybe calculate a key measure, that
Yeah,
sort of thing.
exactly. Okay, let's get into it.
So, first off, what are statistics? The source gets right to it.
It's a science, right?
Yeah, the science of collecting, classifying, interpreting, basically making sense of data, turning numbers into info.
And that brings us straight to data. What is it?
Well, the source defines it simply. A set of numerical facts, collected for a reason.
Like those student marks in the example, just a
Yeah.
list of scores.
Exactly. That initial list, before you do anything, that's your raw data.
Just the numbers as they came in.
Pretty much. And raw data, well, it can be a bit messy, hard to see patterns.
So the first step the source points out is bringing some order, tabulation,
Right, systematically arranging it, usually in tables.
like just listing those student marks neatly.
It's simple as that, yeah. But crucial first step.
Then they mentioned arrayed data. What's that about?
It's taking that same list, say the student marks, but sorting it.
Oh, like lowest score to highest score.
Exactly, or highest to lowest. It's the same data, just
My God.
ordered.
Makes it easier to see the spread, I guess. The lowest and highest marks jump out.
Precisely. You start seeing things,
Yeah.
and that leads into frequency.
How often something shows up.
Yep. So in that marks list, if the score 14 appears 3 times, its frequency is 3.
And 22 appears 5 times, frequency 5.
Okay, and the source shows a frequency distribution table. That's really useful.
Because it lists each unique score and its frequency, side by side.
Mm-hmm. You see immediately where the data clusters, which scores are common, which are rare.
Makes sense. What if you have, like, tons of data points?
Good point. That's where grouped frequency distribution comes in. The source covers that too.
Grouping, like putting scores into ranges.
Yeah, exactly. Like marks from 11 to 20 in one group, 21 to 30 in the next, and so on.
Condense the table, right? Makes it shorter.
It does. You lose a bit of detail, though you don't know the exact scores within the group anymore.
Right, trade-offs. Okay, so we've organized it. Now, making it visual.
Graphical representation. Huge impact. Why stare at a table if a picture tells the story better?
Totally. The source mentions 3 types.
Yeah, 3 main ones. First, the pie graph or pie chart. We've all seen those.
For showing parts of a whole, like percentages.
Perfect for that. Like the example with student exam divisions, how big a slice of the pie is first division, second division.
And the slice size matches the proportion.
Exactly. The central angle is calculated based on the data proportion.
Okay. Then the bar graph or column graph.
Great for comparing distinct things, like the favorite subjects example.
English versus science versus maths.
Yeah.
How many kids prefer each?
Yep. The height of each bar shows the number. Easy comparison.
Yeah.
Equal width bars, space between them.
Clear visual difference.
Yeah.
And the third type.
The line graph. You plot points and connect them with lines.
That seems good for showing change, trends.
Often used for that, yeah, like tracking something over time. The source uses a malaria cases example plotted over dates. It connects the dots visually.
Got it. So tables, then graphs.
Mm-hmm.
What about summarizing everything down?
That brings us to the arithmetic mean.
Which is just the average, right? What most people think of.
Simple average, yep. You add up all your observations,
Like all the student marks.
sum them all up, then divide by how many observations you have.
So the example 8, 7, 10, 6, 11, add them up, 42.
Divide by 5, because there are 5 numbers.
Gives you 8.4.
Okay.
Simple average.
But what if your data is already in that frequency table we talked about?
Ah, right. You can't just average the unique scores listed, can you?
No, because some scores appeared more often than others. You need to weight them.
So how does that work?
You take each score, X value, and multiply it by its frequency.
Okay.
Score times how often it occurs.
Okay, do that for every score.
Yeah.
Then sum those results up. Right, get a total.
And then you divide not by the number of unique scores, but by the total frequency.
Which is the total number of data points you started with, like the total number of students.
Exactly. So in the sources table example, the sum of X times F is 744.
And the total frequency, total students, is 30.
So 744 divided by 30 gives you 24.8. That's the mean for that distribution.
So it's still the average concept, just adapted for frequency data.
Precisely.
Okay. So, stepping back,
Yeah.
what does this all really mean for someone looking at data?
Well, we've gone from just a jumble of raw numbers,
The messy pile.
yeah, haha, the messy pile, to organizing it in tables, seeing patterns with graphs.
And then boiling it down to one number, like the mean,
Yeah.
that kind of represents the center.
These are really the fundamental building blocks. Understanding these helps you understand almost any data set you come across.
It really sets a foundation, doesn't it? Which kind of leads to a final thought. If you recognize these basic structures, raw data, tables, the different charts, the average, how does knowing that foundation help you critically look at the stats you see every day?
Mm-hmm.
In the news, at work.
Mm-hmm.
Does it help you ask better questions about what those numbers or charts are really telling you? Or maybe what they're not telling you?
That's a great question to ponder, something to think about.